Hey, what's up guys? My name is Jimmy and welcome to my channel Envisage. On today's lesson, we will discuss all the different mechanisms of oncology drugs. So besides the chemo man, where we're kind of forced to learn all the different letters corresponding to the chemo man itself, we will utilize the airport as an analogy to tie on not only the concept, but as well as the drug itself. So the airport is a great way because not only is it fun, there's a lot to eat, but it also has some of the many themes that is critical to understanding of how these oncologic drugs can potentially help work. So we will first start off with the broad spectrum chemotherapy, followed by the hormonal therapy, and lastly, the discussion of immunological therapy. As with all airports, the very first entry point is the checkpoint. So the checkpoint prevents any type of ill malice, preventing passengers from potentially bringing on board guns as well as knives, and to protect the safety of all different passengers. It does not discriminate, very much like the broad spectrum chemotherapy. The broad spectrum chemotherapy does not discriminate against any cells, but it prevents it kills all cells that are potentially rapidly dividing. These rapidly dividing cells include bone marrow cells, hair follicles, as well as the stomach lining. Hence, we have all these effects as myelosuppression, balding, as well as nausea and vomiting. And so the Mad Hatter can actually be utilized as an analogy to envision the broad spectrum chemotherapy. The Mad Hatter has a MAD plan. M stands for microtubule disruption, which includes taxanes and vinca alkaloids. Taxanes stabilizes the microtubules, whereas vinca alkaloids disrupts the microtubule formation. Second, we have A, which stands for alkylating agents. These include nitrogen mustards and cyclophosphamide. So the nitrogen mustard itself holds on to the 2 DNA and therefore cross-links DNA, and thereby preventing the DNA from unwinding. And as a result, the DNA cannot replicate. We then have DNA disruption. So think about any type of folate reductase inhibitor, purine, as well as pyrimidine analogs. We then have platinum compounds, such as oxaliplatin and cisplatin. And finally, anthracyclines, such as irinotecan and etopside. The next big concept in terms of oncologic drugs are the hormonal therapy. When we look at the word hormone, we can actually envision the general mechanism of action of how and where these drugs work. H for hypothalamus pituitary axis, R for receptor blocker, and M for molecular changer. We can actually draw a parallel to how our body utilizes a negative feedback mechanism with hormones called HPA. If the body senses too much androgen is being produced, then it will decrease GnRH production via the pituitary through negative feedback. Similarly, a person with a malicious intent may be recognized by surveillance, such as security cameras, and may be removed from the airport by the security. The drug used in these analogies are called GnRH antagonists, as well as GnRH agonists, as they modulate the production of FSH and LH through the HPA axis, which ultimately leads to a decrease in androgen production. Androgen receptor antagonist competitively competes for the binding of androgen receptor, therefore preventing the binding of androgen to its receptor, ultimately decreasing tumor growth. However, if this person in the airport decides to change their identity by putting on a mask, they may be stopped by security and be forced to take their mask off. And as a result, he will not be able to board the plane. The 5-alpha reductase as well as the aromatase inhibitors prevent the hormonal conversion to the active form of the hormone and therefore prevents the binding to the receptor. Hormones can similarly change their identity through enzymes such as 5-alpha reductase as well as aromatase. If we use inhibitors on these enzymes, we can prevent these identity changes and decrease tumor growth. And lastly, a malicious passenger can be directly blocked from entering an airplane by security. Similar to medications such as selective estrogen receptor modulator, such as tamoxifen, raloxifene, and toremifene, or selective estrogen downregulator known as fulvestrant, which can be used to directly block the entry of hormones that may act as a mitogen or otherwise known as a growth factor, to a cell. Similarly to our passenger is blocked from boarding the plane. And finally, let's take a look at immunological therapy. This area is growing in oncology because for the body to kill the very last tumor cell, we have to rely on our body's own immune system to do so. It has been also shown to cause the least amount of side effects in comparison to both hormonal therapy and broad spectrum chemotherapy. When looking at the immunological therapy, it is important to understand the MAPK pathway. The MAPK pathway stands for mitogen activated proteins kinase pathway. The binding of mitogen activates receptor tyrosine kinase, which in turn activates a downstream cascade consisting of RAS, RAF, MEK, ERK, and MYC. This pathway is a series of light chain reactions that serves as a signal to help a cell determine if its need to perform a specific action. This action include but are not limited to cellular proliferation as well as protein synthesis. So, similarly to this pathway of light chain reaction steps, we can visualize how our kid arrives at the airport and makes his way from his house to the airplane seat. He must first sit and plan his trip before he leaves his house to get to the airport. So SIT is our acronym for the different types of oncological mechanism of action. S stands for small molecule, I stands for immunological therapy, and T stands for targeted therapy. So once the kid gets to the airport, a dog is nibbling on the kid to check for any object that would otherwise be prohibited. The dog nibbling represents the suffix of a small molecule inhibitor, stopping the kid from progressing to the airport if he had any objects to be prohibited. So IB is the suffix for tyrosine kinase inhibitor, ZOMIB is the suffix for proteasome, and finally cyclib is the suffix for cyclin-dependent kinase inhibition, such as palbociclib. If the dog does not find anything, then the kid can progress further into the airport, where he reaches the security checkpoint. If anything malicious is found on our kid, he'll be stopped from proceeding further into the airport. So the security checkpoint can be seen as a checkpoint in cell cycle, such as C standing for CTLA4, and then P stand for PD1. Checkpoint inhibition allows immune system to activate. So other forms within this class of immunological therapy consist of CAR T cells as well as CRISPR-Cas9. So finally, targeted therapy. The specific characteristics of our character is what can lead to the security surveillance to identify the person of our interest, such as the goggles that he's currently wearing. This is very much like the specific characteristic of cell known as colonial differentiation. So examples of drugs within this class are CD52, alemtuzumab, CD33, brentuximab, CD20, rituximab, and finally PARP inhibitor. And this concludes all the mechanisms of action for the oncological drugs. Thank you for watching. Please comment below and let me know what other videos you'd like to see next. As always, let's continue to empower a different way to vision success. I'll see you guys in the next one.